Alright guys, we're gonna get started soon. Just waiting on everyone to join the session. Turning on the Q&A. Farzana, Javed, Mazed. Alright, looks like everyone's here. Yep, Nizat, thank you for informing everyone. We are starting closer to 1:30 today. Alright, okay, I see Dangshi, that means Mingmar, Naima. Okay. Okay, let's go PM is here. Guys, just put your names in again when you're here, just so I know that you're here. I think some of you put your names in at 11 when it was expected to start, but I pushed back the start time, not just because of the fact that I wanted you guys to scan through your Namaste books for questions, but because I had to work on some technical difficulties. All right, hopefully everyone's still here, just waiting on everyone to respond and all those good things. All right, Samaya, Taifur. All right, guys, let's just get started. Couple interesting things that we're gonna talk about today. Well, Amazon usually is a little bit quicker. Couple interesting things we're gonna talk about today. For those of you who have class at the center, our next diagnostic. Well, I'm gonna write it in your accounts also. But our next diagnostic is on September 1. At 11 a.m. Got it, guys? So it won't fall during class time, so you have that benefit. And it's going to be September 1 at 11 a.m. Got it, guys? So not so bad. Just keep in mind that you should prepare for that. How would I prepare for that? Well, I would make sure I could do every single question on the previous diagnostic. I am going to give you back your explanations on Thursday. So hopefully that you can study off of that and make sure you know how to do every single question. If you need help, now is the time to ask me, right? You can ask during the online session if you need. You can come a little bit earlier before class starts and ask on Thursday. Fridays I'm teaching, but on Thursdays before class I'm not really teaching anyone. So you can come a little before class and say, okay, I need help with these type problems, these type problems, this type problems control, and that will really help you out. On top of that, a couple of you are emailing me questions, which are very interesting. I believe Ahmed emailed me a question, which is like the 6th root of 32,768 or something. That's a fairly interesting question, and we could definitely work on it. However, I plan on Ahmed, if you want to stay a little after class someday on Thursday or something, I can definitely show you it. The concept is really just something like x squared to the cubed is equal to 32,768, and then you can find the cube root by knowing a set of patterns, and then you can try to find the square root, which is a little bit easier, right? But keep in mind that when you plug that into a calculator, right, when you plug in 32,768 into the calculator, so it would be 32,768, and then you just plug that into the calculator, and let's say this is 6th root we're trying to find. It's going to give us this, which is 5.65, and we can see this is right because if you were to take this to the 6th root, you would get your answer. your 32,768. But take a look at the decimals. It's non-repeating, it's non-terminating, which tells you that it's irrational, right? Which tells you that the answer is going to be fairly convoluted. It doesn't work out so nicely, right? So that's always an area for concern. So I'm not entirely sure why, this is a topic, but it's not really commonly tested on the SHSAT, which is why I'm not really going to focus on it so much and really don't want to waste too much class time on it. But it is an interesting question nonetheless. But that's how you do it, right? So there's general trends for cube roots, which you can take a look. You can do 2 cubed and see what look at the n value, and it's going to be, I'm going to just give a quick rundown. Do 3 cubed all the way up to 9 cubed, and look at the n values. Got it? And then you're going to see that the 2 and the 8 have reversed n values, and you're going to see all of that. But hopefully, we can figure this out at a later date. But on top of that, so your diagnostic is on September 1st at 11 a.m. So square root, cube thing, whatever. Name, when is the Scramble Paragraph Bootcamp? It has been fairly difficult to try to schedule the Scramble Paragraph Bootcamp. We could have done it today, but I don't want to like throw a bootcamp in that short notice. I'm really trying to push for Wednesday. But again, that's a little bit difficult because of the scheduling. So we'll see what we can do. In the meanwhile, feel free to ask me any questions about Scramble Paragraphs or whatever occurs at any point until now to whenever, right? Keep in mind that you will be a lot busier when the school year starts, so now is really the time to focus and try to put all of your all of your mistakes. Got it? Most of you are at the point where based on your diagnostics, most of you are at the point where you really need to try to whittle down, and you really need to be able to know exactly which specific content areas. For some reason, okay, let me just try to figure out some of the chat features. For some reason, I cannot use the Q&A. You can, well, if you're on a computer for Speeda, if you're on a computer, there is a Q&A tab on the top, I believe. On the top, there's a blue Q&A. You can hit that, and then the sidebar opens up. So that's always cool for Speeda. There's not really much. I mean, I guess I can make a video of how to use the Q&A, but perhaps that's a good idea. Okay, yeah, but besides that, that's that. Now, here's the interesting part. This is the Namaste book, right? And the Namaste book is a very, very cool book. Why is it a very, very cool book? Honestly has really good SHSD math problems, right? Really good SHSD math problems. Oh, what time do we start during the school year? Honestly, when the school year starts, I'm not entirely sure if we're gonna run online sessions. I think it's gonna be a little hectic having to do 4-hour, 3-hour sessions during the school year on top of your school homework. So I am probably not going to run the online session school year. Obviously, I'm going to still make instructional videos and still make that kind of, those kind of aids, but I'll probably cease making the online videos when school year starts. Got it? Are you going to check the Namaste on Thursday, and when is the volume 2 scram paragraph due? You guys should have finished the volume 2 scram paragraph on your own. I'm just going to check that over really quickly. I feel like the book does a good job of explaining the steps. And yeah, you guys should be able to really work through that on your own. If you need any help, feel free to ask me. Before class, during class, after class, those times are all wonderful, right? But yeah, here we are on the first test. Now, keep in mind that I have the 2013 edition, but I checked to make sure that the 2014 edition doesn't really have anything different, right? Perhaps there's an error here that's fixed, but nothing really caught my eye. Okay. That's always cool. All right. Any questions thus far? Check your email. I sent you something. I believe you sent me. I believe you asked me about the sessions, the class sessions. I'll get back to you on that. I just have been very tardy with emails over the past couple of days because of how hectic everything has been. But I'll try to get back to emails on a little more of a prompt basis. So we'll try to figure that one out. All right, moving on. So 51. Now, I really don't want to go over this in the sense that I don't want to go over every single question because it's 50 questions and there's going to be 5 practice sets. That's 250 questions. Honestly, that would be you would not. Wait, I don't understand what you said about Namaste and surround paragraph. Namaste. We're gonna go over Namaste today, tomorrow, the next day, however long it takes. Scram paragraphs, you're really on your own on that one, right? Scram paragraphs, you should be working, finishing that handbook at own, trying to make sure you understand anything. I think the book does a good job with the explanations, but if you need any help, obviously feel free to email me. We can set up a session date, or you can come a little bit early before class and ask about any of the Scrum paragraphs, and we can definitely go over that. But I feel like Scrum paragraphs is one of those things where you really have to work with it and practice with it and really excel at it. Now, what I really want to do is I really want to open up the floor to questions. So yes, Java, this is exactly what I want to do. I want Java to say, okay, can you do number 72? Of course I can do number 72, right? So we're starting now, genius. All right. Well, we started before. Well, okay. Well, let's do number 72. 72 is always interesting. 72 is a classic. 72 is a classic. Okay, ready? So I'm just going to zoom in a little bit because this 72 is a real classic, okay? So I really want to show this. Find the area of the shaded face of the cube if RQ is equal to 12. So I'm going to do is I'm going to create a dashed line. Oh, what's happening? Okay, dashed line. Because that's RQ. Now, everyone take a look. See how that's RQ? That's going from the back corner, the back left corner, to the front right corner. And see that? All right, I'm going to go to 55, but let's first look at 72, and then we can move on to 55, right? So it's going from the back left corner all the way here to the front right corner. Got it? Now, what I want you to see, guys, is that if you think about the edges, think about that as the base. I'm just drawing some other auxiliary lines so it makes a little more sense to you. Everyone sees that? Think about that as the base. Well, it should be a little bit lower if you think about it because it should be lining up there, but you guys get the point. Right? But now, see how that's an edge? So, and that's, now, I'm trying to make this triangle. So, I'm going to make this triangle right here. Everyone sees that? I'm going to call this point A. So, I'm going to draw R, AQ on the side just so you get a better idea of what I'm doing. Because this kind of question is very interesting. So that's R on the top, so that's going to be R. That's A. I'm calling that Q. Cool, right? Now I know that RQ is 12, so I'm just going to put that in over here. Now watch this. This is really tough. If I call the edge of a cube X, everyone sees that? Then every edge of that cube is X, because every side of a cube is the same, because it's made up of squares. So that's X. That's X. Now, x, what must its diagonal be? What must AQ be? It must be x radical 2. Why? Because this bottom face, okay, that's fine, Juhan. But this bottom face, this bottom base is a square, right? So if I draw the square, right? Juhan, just try to follow on for today, and you should be fine, right? If you encounter any problems, obviously you have tomorrow and the next day and the next day to ask questions, right? So this bottom face is going to be x. X is a square. So a square is made up of 2 45, 45, 90 triangles. What's the ratio for 45, 45, 90 triangles? X radical 2. Got it? Because that's 45, because the 90 is split. That's 45, and that was 90, because every square is made up of right angles. So x radical 2. Everyone sees that? So that's x radical 2, and that's x radical 2. Now let's do the Pythagorean theorem. So x squared plus x radical 2 squared, right? The side squared. Pretty much I'm doing a r squared plus aq squared is equal to rq squared. So x squared plus x radical 2 squared is equal to 12 squared. X squared is just x squared. X radical 2 squared, well, radical 2 squared is 2. X squared is just x squared. 12 squared is 144. Now, x squared plus 2x squared is 3x squared. That's equal to 144. Divide by 3. X squared. Well, I'm feeling a little bit lazy today. 12, 24, 46 perhaps. Yeah, that looks to be it. X squared is 46. So square root, x is equal to radical 46, right? Does that make sense, guys? Radical 46. Let me just double check to make sure. 4, 12, 2, 4. No, radical 48, right? X squared is 48. 3 times 48 is 144, right? 120, yep. 3 times 48 is 144. So square root, x is equal to square root 48. Okay, Johanna, I'll go over 99 and 100. So x is equal to radical 48. I can simplify that, but I'm not going to do that just for a second. Well, I'm trying to find the area of the shaded face. That's really what I'm trying to do. Well, the area of the shaded face is a square, right? See that? It's a square. Well, each side of that square is going to be x. So what do I know x is? Radical 48. So that's radical 48, and that's radical 48, right? So how do I find the area of a square with side radical 48? Well, radical 48 times radical 48, which is side squared, is just equal to 48. So the answer is going to be F. Got it? Before I move on, does that make sense to everyone? Got it? Does that make sense? It's a very interesting problem. I hope it makes sense to everyone. Got it? Try to go slowly, but hope it makes sense to everyone. All right. Let's move on. Let me see what other questions I had. Let's start from the bottom. Type 4 was first with number 55. It's like a truck alarm by my house. I don't know why, but I guess we have to deal with that. All right, let's take a look at number 55, right? Now, this is like an operation thing. Comes up a lot on the SHSAT. Very common, not really that difficult, but you really have to be slow and patient and work through it. Got it? So we know that K symbol. Therefore, you didn't get the previous one. You didn't get that one. Well, do yourself a favor. After the session ends, just rewatch it. Got it? Just rewatch it in slow motion and try to do it as I do it. It's gonna make a little more sense. Got it? All right, now let's take a look. 55. Now the idea for this equation is that we have k, and then k. Let's just make this sun. K sun t is equal to k minus t plus 3. K minus t plus 3. All right, we're gonna get to all of them, guys. Don't worry. 55, 60, 60, 70, 70. We're gonna do all of them. All right. Now, so we have to do this first. Got it? We're gonna plug in 3 for k and negative 2 for t. So what do? We do 3 for k, so that's 3, minus, now we do t. What's t? Negative 2. So minus negative 2. Then we do plus 3. 3 minus negative 2. When you have negative, negative, that's plus. So that's 3 plus 2 plus 3. 3 plus 2 is 5. 5 plus 3 is 8. So what did I just do? All of this is equal to 8. Now, what am I left with? I'm left with 8, sun, whatever, 1. Same process. What's my k value? 8. What's my t value? 1. So what do? K minus t, so that's 8 minus 1 plus 3 plus 3. 8 minus 1 is 7. 7 plus 3 is 10. Boom. Got it, guys? All right, let's see what else I can do. I believe the loan was after that one. Loan said 95, 96, 97, 98, 99. And that kind of takes care of Drew Hunter because Drew Hunter's like 99 and 100. All right, so let's do it. All right, guys, let's see where we are. I'm 96. 96. Let's do 96. We have there are twice as many girls as there are boys in a math class. The average score of the boys on recent exam is 90, and the average score of the girls in the same exam is 93. Where's the average score of the entire class in this exam? Okay, now let's say number of boys plus number of girls. But let me try to equate the variables just a little bit. We know that number of boys plus number of girls divided by 2, well, the scores, right, sums of their scores, is going to equal to what we want, right? But now we have like a couple variables and we don't really know what we're doing. But we know what? There are twice as many girls as there are boys. So we know what? That for each boy, there's 2 girls. Got it? So we should count that twice. So what should we do? We should, instead of having a boy, well, we know that each girl, so let's let boy equal x. Now girl, well, there's 2 girls for every boy. So girls can equal 2x. Everyone sees that? So x plus 2x, but now we're adding 3 things, right? So over 3 is going to equal, well, our average. Well, what's my boy average? My boy average is 90. What's my girl average? My girl average is 93. So I'm going to do 2 times 93, just plugging in for x, over 3 is equal to my average. That's my answer. 2 times 93 is 186. 186 plus 90 is going to be 186 plus 90. 186 plus 90. That's 176 plus 100. That's 276. 276 divided by 3 is equal to my average. 276 divided by 3 is 92. 92 is my average. Got it, guys? Not so bad. All right, 90. Oh, we did 96, but we didn't do 95. If 100 consecutive multiples of 3 are written down in order, what could be the difference between the largest and the smallest number of the set? That's interesting. Well, think on a small scale. Think about 3 consecutive multiples of 3. Well, what would you have? You would have x plus 3 plus x plus 6. Right? Cool. Interesting. Interesting. Now, what would be the difference? 6. Well, what if you had 4? Well, then it'd be x plus 9. See that? Well, what's this? That's 3 times 1. That's 3 times 2. That's 3 times 3. Well, let's say you didn't want 4 and you didn't want 3. Well, then you could have, how about 5? Well, you'd have x plus 12, which is 3 times 4. But notice how your smallest one always stays at x. It's really your largest one that's changing. Well, if 5 consecutive multiples has the maximum at x plus 12, and 4 consecutive multiples is the maximum at x plus 9, and just 3 times 4 and 3 times 3, then the 100th multiple should be 3 times 99, no? If this is the fifth multiple and it's 3 times 4, then the 100th multiple should be 3 times 99, one less than the number of multiples. Well, 3 times 99 is going to be, 297. So the 100th multiple is going to be x plus 297. Now, the smallest multiple is x. So x plus 297, we're looking for the difference. Minus x, well, x minus x cancels out, you're left with 297. Moving on. Number 97. Oh, he didn't say 97. Let me see if Drew wants 97. No, 200. So 98, 99, 100. Let's do those. Two sides of an isosceles triangle are 17 and 8. What is the perimeter of the triangle? Well, honestly, you can't really say definitively, right? You can't really say definitively, but let's take a look. You would think, because there's two possible options, right? There's one possible option. Here's triangle 1. Well, let me just try to make a better triangle, because now I have this shape creation thing. Well, that doesn't look like an isosceles triangle, does it? Let's just do this. No. This one? That's nice. Right? That's one. That's two. Now there's three possible. Well, there's three ideas that we could do here, right? And the three ideas are, well, the two ideas are this. Two sides of an isosceles triangle are 17 and 8. Now, if you take a look, that could be 8, 8, 17, or 17, 17, 8. Now, I want you to take a very careful look at both triangles. You should be able to see that 8 and 8, 8 plus 8 is 17. 8 plus 8 is 16, and 16 is less than 17. This tells you that this triangle cannot be proper or cannot be constructed. Why? Because in the triangle inequality, states that the sum of the two legs must be greater than the third leg. So this is not a proper triangle. Everyone sees that? It can't happen. So we're left with this. 17 plus 17 is 34 and is larger than 8. 17 minus 8 is 9, and that's smaller than 17, so that's perfectly fine. So what is the perimeter of that triangle? Well, 17 plus 17 is 34. 34 plus 8 is 42. So 17 plus 17 plus 8. 34 plus 8 is 42. H is the correct answer. You said, how did he get 276 from 96? Let me quickly answer that. 276, I added 90 plus 2 times 93. For every one boy, I'm counting 2 girls. And how to go from over 2 to over 3? Because here I had 2 parts, I had boys and girls, but here I have 3 parts. 1 boy, 2 girls. 1 boy, 2 girls. 1 boy, 2 girls. Got it? Oh, I didn't see the how to go from 2 to 3 questions, but on number 96, it goes from 2 to 3 because here we have 2 parts, boys and girls. But here we have like 3 parts. Well, we have the 1 boys and then we have 2 girls. 1 boys, 2 girls. 1 boys, 2 girls. So we have 3x. When we add this, x plus 2x is 3x, right? And 3x is 3 parts, so you gotta divide by 3, not by 2. Keep that in mind. And even if you were to divide by 2, you would get an extremely high number. You would get 276 over 2, which would be 138, and you'd recognize that, hey, that can't be the average if there's 90 and 93, right? It'd be something near there, which would be 92. Any questions so far, guys? Any questions so far? Okay, moving on. 98, then 99. 99. We have, in order to fold a box, Peter cut 4 small squares from each corner of a square piece of cardboard. If the original piece was 10 inches on the side, and each of the small squares is 2 inches on the side, what would be the volume of the folded box? Well, volume is always length times width times height. Now, here's what happens. He cut these 4 small squares. These 4 small squares are like over here, 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 and here. It used to be like a square piece of cardboard. So it used to be all the same size. Now, if the original piece was 10 inches, Yeah, your logic is right for the old question, yeah. But yeah, so now let me just erase this so we can better see this, right? But the idea is that we have the original piece was 10 inches, right? So that's 10 inches on a side. Now we know what? Each of the small squares is 2 inches on the side. So that's 2 and that's 2. Well, 2 plus 2 is 4, making this 6. Same thing here. 2, 2, 6. Okay, now we know that each of the squares is 2, so that's 2 also. See that? Well, how would you find the volume? Well, length? Well, honestly, you just do the dimensions. So it would be this times that. Got it? So that'd be 2 times 2 times 6. 2 times 2 is 4. 4 times 6 is 24. Right? Double check that though. Make sure we have the same volume. Do we have that? No, actually no. Because why? Why is that not going to be the case? Because what's going to happen is this is going to form to make one edge. It doesn't form to make two edges. Got it? So that's not going to quite be the case. Instead, what's going to happen is this is going to fold up. 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 This is going to fold up, right? And we're really going to form like a box per se. Not like a complete box, but like a half a box, right? Because there's no top. I don't see a top here, right? We just really have the edges. Now, take a look. In that edge, we really have this as our top. That's going to be one of the top edges, right? Like this over here. Then we're going to have this as our height, right? Or this one, or whichever one. And then we're going to have this as our like width. So it's really not going to, it's going to be 6 times 6 times 2, which is 72. That is a little bit confusing because it's like an open top box, if you can see. Usually closed top boxes look something like because this thing is going to be your like your top. That's going to be like your side. That's your base. That's the left side. And that's your like front side. And that's your right side. Right? Usually closed top boxes look like this. This is an open top box. That's just a little bit weird. Okay. Number 100. Yeah, we're going to go over all of them. Don't worry, Mazad. 100. We did a question like this before. What's the smaller angle between the hour and the minutes hand of the clock at 5:10 p.m., right? So I'm just going to draw a circle. And let's do this. So we do what? We do 12. We do 6. We're going to get through all of them, guys. Just give me a second. 3, 9, 1, 2, 4, 5, 7, 8, 10, 11. Do my center. Now, 5:10. 5:10 looks something like, well, a little bit less to the center, so. Got it? That's 5:10. Now, here's what I want you to see. We know that there's 12 sectors, and it equals 360 degrees because circle is 360 degrees. So 360 divided by 12 is 30. So every sector is 30. Now, if we're to break this up down into sectors, this is 30 degrees. This is 30 degrees. This is 30 degrees. Now, take a look. How do I find this? How do I find this? Well, let me zoom in a little bit so you can see it better. How do I find this little bit right here? This little bit. How do I find that? Well, if I take a look, we know that we're at 5:10, right? And 10 minutes out of 60, because the entire hour is 60, that's 1/6 of a sector. So if you're doing 1/6 of a sector. So we know every sector is how many degrees? 30 degrees, right? So 1/6 of 30 degrees is 5 degrees, because 30 divided by 6 is 5. So that's going to be 5 degrees. If we were at 5:30, what would you do? Well, 30 over 60 times 360. Well, not 360, 30. So that's going to be 1/2 times 30. So that would be 15 degrees. But we're not. We're at 5:10. So only 5 degrees. 30 plus 30 is 90. 60. 60 plus 30 is 90. 90 plus 5 is 95 degrees. And that's going to give us J. Okay. Now let's see what other stuff we can do. What other stuff we're going to do. I don't get 70. Let's go over 70. The ratio of the sum of my favorite number and 9. Let me just see. Yeah, okay. 70. Just give me 1 second, guys. Just got a email. Let me just quickly reply to this email. Okay. The ratio of the sum of my favorite number and 9 to 15 is the same. And 9. So the sum of my favorite number 9. So let's say that favorite number. Let's say I for Imran. So I plus 9 to 15 is equal. Let me just make sure that's clear. The sum of my favorite number 9. So I plus 9 to 15 is equal to 3 to 5. Everyone sees that? Well, how do I make 3 to 5 look like 15? Well, make look I plus 9 to 15. I can equate the second part. Got it? So how to do that? I'm gonna multiply this ratio by 3. So what happens then? It becomes 9 to 15. Everyone sees that? Now look. So when you multiply ratio, it stays the same because think of ratio as like a fraction, right? Because ratios can be expressed as fractions. Now 3 to 5 is saying same thing as saying 6 to 10 is the same thing as saying 9 to 15. So I'm not changing the ratio. I'm just pretty much getting another like multiple of it. Now if I plus 9 to 15 is the same thing as 9 to 15, well, it becomes very clear, right? That I plus 9 must be equal to 9. So I plus 9 is equal to 9. Subtract 9. I must be equal to 0. Got it, guys? Pretty easy. Okay. 62, then we're going to OPM is 54, 55. Oh, a lot of people said 54, 55, 56, right? Let me just go over that quickly first then. Okay, let's do 54, 55, 56, 59, 62. Okay. Let's see this. 54. Alright, so 54, what were we given? Well, we're given that one side of the triangle is 4 centimeters, and the sum of the other two is equal to a whole number of centimeters. What is the smallest possible perimeter of this triangle? Well, let's take a look. Well, we have a triangle. Let me just draw one of these triangles really quickly. Whoa. Do which one again? Miami. Now, we have this triangle. One side of the triangle is 4 centimeters. Cool. We're told that the sum of the other two is equal to a whole number of centimeters, right? Can we just go over everything? Yeah, sure, we can go over everything. Okay. Now, one side of the triangle is 4 centimeters, and the sum of the other two is equal to a whole number of centimeters. What is the smallest possible perimeter of the triangle? Well, this honestly, you should be doing some back solving here. Really, a couple ways you could do this, but I would probably do some back solving. what I would do, well, if you take a look, you know that well, there's a couple of inequalities that you can make, but I wouldn't do that. I would just say, hey, let me start with 11. Does 11 work? I always start with C when I'm back solving. So if this is 11, let's say call this 3, and well, that's 7 already, and that's 4. Does that work? It works. 4 plus 4 is 8. That's larger than 3. 4 minus 2 is 1, and that's larger and that's smaller than 4, right? So it does work. So 11 works. Well, let me try with 10 now. Well, how about 10? So if I have 10, so I'm using the triangle inequality to check them. So if I have 10, I can make this, let's just make this 3 and 3. Well, that works also. 4 minus 3 is 1. That's less than 3. 3 plus 3 is 6. That's more than 4. 4 plus 3 is 7. More than 3. So that works also. So let's try F. Maybe F won't work. Well, now we're dealing with 9. So let's do, we have 4 ready, so we have 5 and 4 left. So let's do, no, we have 9, we have 4 ready, so we have 5 left. So let's do 3 and 2. Well, 4 minus 3 is 1. That's less than 2. That works. 3 plus 2 is 5. That's more than 4. That works. So F is the correct answer, because it's the smallest. Even though G and H works, F is smaller and it works. So, and they asked for the smallest. All right, moving on. 55 we did. 56. 56 is interesting. Well, the letter H stand for no that letter H stand for non-zero digit. The three-digit number HHH is always divisible by what? Well, guys, I want you to take a look. Let's say we had 321. No, I want to give a better number. Let's say 324. Well, what would that be equal to? Well, that's technically equal to 3 times 100 plus 2 times 10 plus 4 times 1. Right? As in value, making those digits into value. That 3 is equal to 300, that 2 is equal to 20, that 4 is equal to 4. Well, let's do the same thing over here. Well, that's going to be 100h plus 10h plus 1h. Well, 111h. Everyone sees that? Well, that kind of looks weird, but 111h. Got it? Now, it's always divisible by 3. Why? Because the divisibility rule for 3 is if the sum of the digits add up to 3 and is divisible by 3, or not add up to 3, but it's divisible by 3, then the number is divisible by 3. So since 1 plus 1 plus 1, which is the sum of the digits, equals 3, and that is divisible by 3, $111 must be divisible by 3. Wonderful. All right. 59. Let's see. It is known that 2x minus 3 over x equals x plus 1. What is the value of x squared minus x plus 3? Well, let's take a look. Well, 2x minus 3 over x is equal to x plus 1. Interesting. So now I'm going to multiply by x. Fun story, Mazad. So that's going to be left with 2x minus 3. We'll distribute the x. X times x is x squared. X times 1 is x. Now I want to make one side equal to 0. Got it? That's always what I want to subtract 2x. Subtract 2x. What am I left with? Negative 3 is equal to x squared. Well, negative 3 is equal to what? X squared minus x. X minus 2x is that. Then add 3 to both sides. I'm pretty much left with x squared minus x plus 3 equal to 0. Now, what am I asked to do? I am asked what x squared minus x plus 3 equals to. Well, X squared minus x plus 3 equals to 0. Got it? That's pretty simple. Alright, looks like we're going to keep on going. Let's do 62, which is going to help type 4 and OPAMI. 62, let's look. It looks like a fun one. Let's see. We know that MNPQ is a square. That's cool. We're also given that MP is equal to 8. So this diagonal right there is equal to, I'm just going to write that on the side. MP is equal to, I don't want to mess up the diagonal just yet. Unshaded region is 1/8 of the square's area. Find the area of the shaded region. Interesting. Okay, well, I'm going to just find the area of the square. Well, if unshaded region is 1/8 of area of square, then the shaded region must be 7/8 of area of square. There's a couple ways to do this, but I honestly think the easiest way is this. You guys see how MP is equal to 8? That pretty much means that that is equal to 8. Now, we know that the diagonal of a square, based on all the other problems, x, the diagonal must be x radical 2. Well, x radical 2. So, 8 is equal to x radical 2, divide by radical 2, divide by radical 2. That means the side of the squares is 8 divided by square root 2. 8 divided by square root 2. How do I find the area if a side is equal to 8 divided by square root 2? Well, how do I find the area? Well, area of a square is side squared. So, side is 8 over radical 2. So, that's 8 divided by square root 2 squared. 8 squared is 64. Square root 2 squared is 2. 64 over 2 is, well, let me just move over my thing a little bit. 64 over 2 is 32. That's the area of the entire square MNPQ. We're looking for the shaded region, though. How do you find the area of the shaded region? Well, we know that the shaded region is 7/8 of the area of the square. So 7/8 of, what's the area of the square? 32. Well, 8 into 32 is 4. 4 times 7 is 28. Got it, guys? Not so bad. All right. Let's see what else we have to go over. We did quite a bit so far, right? I need help with 62. We just went over 62. J95. Does that mean you need help with 95? But let's go over 70, 71. Opayami and Javed. Quickly do those again. Opayami and Javed. We'll just do those. $70 and 75. We did 70. So 71, perhaps? 71. Interesting. The average of all the degree measures of all angles of an octagon is less than the average of the degree measures of all angles of a decagon by what? Interesting, easy, formulaic question. So, how do you do this? Well, here's what we do. The sum of all interior angles in any polygon is equal to 180 times n minus 2. To find the average interior angle in any polygon, just divide by the number of angles, which is n, right? Number of angles is equal to the number of sides, right? So n. So 180 times n minus 2, that's the sum, divided by the number of angles for sides, which is n. Boom. The average of all degrees of an angles of an octagon, well, let's do it. Octagon, average octagon, well, that'll be 180 times 8 minus 2 divided by 8. That's 180 times 6 divided by 8. We know that that'll be 3. That'll be 4. 4 into 180 is 45. Is it? No, 4 into 180 is not 45. It's 90 over 2. 90 times 3 is 270. 270 over 2 is 135. You can do the calculations. I'm trying to do them in my head. Average decagon, 180 times 10 minus 2, because 10 is the number of sides, right? Let n equal number of sides. So now you just plug in 10 over 10 because over n. So 180 times 8 over 10. 10 into 180 is 18. 18 times 8 is 80 plus 64, which is 144. So that's the average angle in a decagon, and 135 is the average angle of an octagon. So 144 minus 135 is equal to 9 degrees. D. Okay, moving on. So we did 71, we did 62, we did all the ones you guys said. Alright, let's take a quick break until like, I don't know, 12:30. Go over some more, right? Have more questions ready. I think 74 is an interesting one you guys should try. Right, let's have more questions ready. Got it? So let's take a break until 12:30, find some questions, and then we'll keep going. Got it? Break until 12:30, guys. Something is wrong with the microphone. It sounds blurry. That's pretty interesting. It shouldn't sound blurry. But maybe it's me. Yeah, we can go over all the questions after break. Perhaps we can try. All right. Alright guys, I think the microphone should be working, but are we back? Put your name in the Q&A and then we'll try to go over all the questions that we missed. Alright guys, put your name in the Q&A and then we know we're back. Alright? Wait, you guys can't hear me? Alright guys, you should be able to hear me. Yeah. Alright. Wait, can you guys hear me? Put your name in the Q&A and then we'll get started, guys. Come on. We're not all day. Alright. Okay, let's do this. Well, I don't usually talk during breaks, which is why I usually mute the microphone, so you can't really hear anything. Alright. As for how are we going to do this? Well, yeah, we're gonna go over 51 to 100. We're gonna go over the questions that we didn't do yet, so hopefully that is everything. Alright, we did go over quite a few questions already, so that's not exactly everything, but alright. Let's get started. Increasing the original price of a ticket by 12% and then increasing the new price by 13% is equivalent to increasing the original price by what? Well, couple things you could do here. Honestly, what I would do, you could plug in a number if you had to, right? You can say let original price equal $100, right? Then what? You're increasing it by 12%. So new becomes what? What's an increase of 12% of $100? Well, it becomes $112. Then what? Then you're increasing by another 13%. Well, what's 13% of 112? Well, really quickly, 13% of 112. So 0.13 times 112. Boom, 14.56. So add that to 112, and you're dealing with $126.56. Got it? So my newest is 126.56. So I started at 100. I'm now at 126.56. How do I see percent change? How do I see percent change? So new minus old over old, right? So that's 126.56 minus 100 over 100. So that's going to be 26.56 over 100 times 100. That's 26.56%. It never tells you to round to the nearest tenth or anything. So, see. Got it, guys? Plug in a number. Not so bad. 52. If a and b are prime numbers, which of the following cannot be the sum of a and b? Well, these are all small. So, let's think. Well, we know prime numbers are like 3, 5, 7, 9, 11, 13, 15. Not 15. 19, right? So let's see. Well, we got kind of like think over here, right? Well, we know what? Well, we know that like every single prime is like odd except for 2. So, and we forgot 2, which is very funny. Right now we know what. Well, let's take a look at addition formulas. Well, odd plus odd is equal to even, right? So we know what. Well, usually our answer is going to be even, except for 25 and 27. So really, we have G and H as possible answers, right? Now, that doesn't rule out everything else because, hey, A could be 2. So let's take a look. Over here, since we have a odd sum, that means that we must have one A or B must be an even number. And the only even prime is 2. So 2 plus what is equal to 13? 2 plus 11 is equal to 13. Are these both prime? Yeah, those are both prime, so that's fine. How about this one? This one is another one where it has a odd sum. In order to have an odd sum, you must be adding an even plus odd, right? So what can you do here? Well, you have your sum is 25. So what do you want to do? Well, we know that one of them must be 2 because 2 is the only even prime number. So 2 plus what is 25? 23. Both are prime numbers, so J works also. How about K? Well, again, same thing. 2 must be one of the must be A or B because the sum is odd. Now what's left? 25. Is 25 a prime number? Definitely not. So K does not work, making it the incorrect answer. Well, making it the correct answer. So K is our answer. 53. We did that. 54. Did that. 55. Did that. 56. Oh yeah, not 9. Good job, OPM. I was trying to think like what you're saying. Not 9. But 56 did that. 57. How many one-digit integers are in the interval between -5 and 3.02? Well, it says between and one-digit integers, right? So keep in mind that 0 is an integer, right? So let's do this. Well, -4 is between -5 and 3.02, -3, -2, -1, 0, 1, 2, and 3. 3 is between -5 and 3.02, just under 3.02. So how many do I have? 1 here, 2, 3, 4, 5, 6, 7, 8. 8. The answer is going to be D. Moving on. What is 10% of 7/8 of 160? You always do 7/8 of 160 and then you do 10% of it. So what's 7/8 of 160? Well, 8 into 160 is 20. 20 times 7 is 140. So that's 140. Now you're trying to find 10% of 140. Well, just take off a 0. Just 14. Boom. G. Not difficult. All right, we did 59. Moving on to 60. If p is a positive integer, then p times p plus 1 times p minus 1 is always divisible by what? Well, let's take a look. Well, kind of interesting. Now you can plug in a number. Let p equal, well, let's just do it for something like 2. Rather just go for something like 2, right? So let's do 2 times 2 plus 1 times 2 minus 1. That's going to be 2 times 3 times 1. Now let's do another one. Let p equal to, I don't know, 6. So that's going to be 6 times 6 plus 1 times 6 minus 1. So that's 6 times 7 times 5. What are these both multiples of? Well, not 5, because that's not a multiple of 5. Not 7, because that's not a multiple, because the first one's not a multiple of 7. Well, it could be a multiple of 6. But I don't see that as an answer choice. Oh, 3 goes into this, and 3 goes into 6, so 3 goes into this also. So it looks like 3 is our answer. I didn't do 53. I did do 53. Take a look. Oh, no, I didn't. That was the work for 56. Okay, 53 really quickly, guys. Sorry for flipping back. But what is the smallest possible average of 5 distinct positive even integers? Well, to get the smallest possible average, you want the smallest possible numbers, right? That makes sense. So what's the smallest possible positive even integers? Well, just use 0 count here. No, 0 doesn't count because 0 is not positive or not negative, right? So we know what? It's going to be 2. Well, 5 distinct, so plus 4, plus 6, plus 8, plus 10. What's the average of them? Well, when you have average of consecutive numbers, just a little shortcut, you can just find the median. It's going to be 6. Got it, guys? Not so bad. Whenever you have the same difference between the terms, like you see I was going up by 2, it could be going up by 3 or going up by 4 or even going up by 1, you can just find the median to find the average. You don't have to actually add them up and divide by the number of numbers. Okay, 61. If h is greater than 3 and h minus 2g is equal to 0, which of the following must be true? I don't know what that's supposed to say, let alone, but interesting. H minus g, 2g is equal to 0. So h minus 2g is equal to 0. Add 2g, add 2g. We're left with h is equal to 2g. Now, I'll my answer in terms of g. So I'm just going to divide by 2, divide by 2. H over 2 is equal to g. I'm going to plug in h over 2 for h. Well, I'm going to try to make it. I can't do that because that would change the inequality. So I'm just going to play with that. H greater than 3. Well, I want h over 2 because h over 2 is equal to g. So what I want to do is I'm just going to divide by 2. Divide by 2. H over 2 is greater than 1.5. And we know that what? H over 2 is equal to g, right? So instead of h over 2, I can just put g. Let me just write it over here. I can just put g. Well, I can't write it, but you guys get the point. I can just put g is greater than 1.5, right? Because h over 2 is equal to g. It has a scratchy echo. Let me see if I can fix that. Maybe my gain is too high. All right, hold on. Let me try to see something. You guys are saying it lags a lot. All right, I have the gain turned all the way down. How about now? Does it lag a lot now? I've kind of turned the gain down quite a bit. Any idea on the voice now, guys? Should be a stellar microphone. It looks like I'm doing pretty well. I don't know, but it looks like I'm not doing so shabby on my outputs. Still a scratchy echo, guys? Still a scratchy echo? Huh, guys? I've taken out the pop filter, but I don't know if that helps. Any questions, guys? I'm not sure what to do with the microphone. I guess I could do some stuff, but I think it sounds fine on my end. I can hear it. Better? Is the sound quality better, guys? Maybe I should turn the gain down a bit. Maybe that'll turn down the echo over here. But Okay, hopefully that helps. Maybe you have to turn up your volume, but that shouldn't be too much of a problem. Got it, guys? Hopefully that helps. All right. So let's get back to work. Now, so we just finished 61. Now let's go on. We have 62. We just finished 62. Now let's do 63, right? Okay. Drink some water. What is the smallest integer that is the sum of 3 different primes, each of which is greater than 10? So to give the smallest integer, well, the smallest sum, perhaps, we want the smallest prime numbers that are greater than 10. So what are the smallest prime numbers that are greater than 10? Well, 11, 13, and 17. Right? 15 and 16 doesn't work, and 12 doesn't work. So what's 11 plus 13? Well, 24. 24 plus 17, 41. 63 is A, and that was pretty easy. 64. If it takes 6 identical copy machines to make 180 copies in 1 minute, how many copies could 10 machines make in 5 minutes, right? That's interesting. Well, I want to kind of think about it this way. So we have 6 copy machines. I'm just going to call them copiers. 180 copies, 1 minute. There's a lot of relationships going on here. At the same time, we have 10 machines, 10 copiers, and we have 5 minutes. Everyone sees that? Now, let's take a look. There's a couple things you could do here. The first thing I want to do is I want to get a unit rate. So if I divide by 6, it's still doing it, as in it's still lagging. Just give me a second, guys. Let me check my internet speed. My internet is fine. 50 download, 5 upload. But I'm not entirely sure why the sound is not so great. Maybe it's the computer, but I doubt it's the computer. All right, guys. But just give me 1 second. Let me see what I can do here. All right. I'm not entirely sure why the sound is bad, but it shouldn't be. All right, you guys should be hearing like a whirring noise, trying to cool down the computer a little bit. Maybe it's that. I'm not entirely sure why the sound is like that. Hope this doesn't take too long. It's cooling it down a bit, but I keep getting auto signed out. Well, what browser are you on? Are you on two things at once? I'm not entirely sure why you're getting auto signed out, but try to log out of everything, and then maybe that will work. That'll help for you. That'll help you out. I'm trying to cool down the computer right now. Hopefully that helps. Maybe my computer is trying to do too much at once. Alright, if you can hear the whirring sound, I don't have to move closer to my router because, take a look at my internet speed. Let me see if I can show you that. I don't think my internet speed is really the problem, but I mean, I have pretty good reception throughout my entire house, and it's wired. I hope this doesn't take too long, but let me see. I'll show you guys my internet speed just so you can see that it's not really anything I can do to fix it. It's definitely not the internet. Alright guys, I am going to continue in about another minute. Not entirely sure why, but okay, gonna turn on the fans. Everything should be a little bit cooler now. Okay, let's do it. Not really much I can do in terms of like my computer lag. It's the highest end MacBook Pro Retina 15-inch, the best laptop that Apple sells. But I'm not really seeing anything I can do to help fix that lag. But I guess for next time we could work on that. Alrighty, guys, let's do it. Now, I want you guys to divide by 6. Divide by 6, right? On both sides over here, right? So anyway, we can speed the system. I'm gonna work on that maybe tonight. I'll let you guys know tomorrow. Maybe we'll do a new system tomorrow. But honestly, you know, I have invested in the top-notch internet, top-notch, you know, microphone quality, top-notch computer. So not really entirely sure why any of the hiccups are happening. But what can you say? All right. Well, we're gonna divide by 6 all throughout, right? So divide by 6, we're left with 1 copier. 6 goes into 180 copies. That's gonna be 30 copies. And it's not going to change the amount of time. We don't have to divide 1 minute by 6. Why don't we have to do that? Because you kind of have to look at the relationship here. More copiers, more copies, or less time. So if you think about it, if we have more copiers, we can have more copies in the same amount of time, or we can have the same amount of the copies in less time. Does it make sense, guys? So you don't really have to divide 6 into all of them. Well, you shouldn't divide 6 into all of them. 1 copier can provide you 30 copies in 1 minute. So 1 copier, 30 copies, 1 minute. Now we're giving the thing 5 minutes. I'm going to multiply it by 5. And I don't have to multiply the 1 copier because I'm still going to have the 1 copier, and I'm going to have to be able to create 150 copies in 5 minutes. So if 1 copier can create 30 copies in 1 minute, obviously you can create 150 copies in 5 minutes. Now I'm looking for 10 copiers in 5 minutes, not 1 copier. So multiply by 10. I don't have to multiply by number of minutes, just multiply the number of copies and copiers. So 10 copiers leads to 1,500 copies in the same 5 minutes, right? And that should make intuitive sense also. If 1 copier can make 150 copies, then 10 copiers should be able to make 1,500 copies, right? And that's pretty much it. 10 copiers, 1,500 copies, 5 minutes. Gee, got it, guys? Not so bad. Number 65. Let's keep going. How many prime numbers are divisible by 11? Well, the answer is easy. Just one. 11. Because 1 times 11 is 11. No other prime number, because any other multiple of 11 will have another factor. And prime numbers can only have 2 factors. So, E is the answer. Got it, guys? Not so bad. 66. We have radical 3 plus radical 3 squared, right? So radical 3 plus radical 3 is going to equal 2 radical 3 squared. Now 2 squared is 4. Square root 3 squared is, well, 3. 4 times 3 is 12. Number 67. If a 25% deposit that has been paid toward the purchase of a bookshelf is 120, how much more remains to be paid? Well, we have a 25% deposit that is 120. So 25% is 120. So how much do you have left? Well, you have 75% left, right? And 75% is 3 times 25%. So that's 3 times 120, which should just equal 360. Got it, guys? So not so bad. All right, 68. It says how many integers D, not what values of D, but how many integers D will satisfy the inequality through 2 less than 3D minus 4 less than 11. So what do I do here? I'm just going to add 4, add 4, add 4. 2 plus 4 is 6. 6 less than 3D less than 15, right? Whatever I do to one side, I have to do all 3, right, guys? Now, gonna divide by 3. Gonna divide by 3. Gonna divide by 3. 6 divided by 3 is 2. 3D divided by 3 is D. 15 divided by 3 is 5. So, how many integers of D are between 2 and 5? Well, we could have 3 and we could have 4. That's it. So, 2 values. Got it, guys? Moving on. 69. 69 is a very interesting problem, right? 69 is a very interesting problem. Let's take a look. Honestly, you could do this a multitude of ways. Some people will suggest that you try the choices, and sometimes that works. So back solving. Let's try to look. So the product of 2-digit numbers mn and nm is equal to the 3-digit number nkn. So mn times nm is equal to nkn. Cool. If k, m, and n are 3 different non-zero digits, and the sum of k and n is 7, what is the 2-digit number mn? Okay, that's interesting. Well, there's a couple ways you can kind of cut this down for yourself and make it a little bit easier for yourself. Now take a look. We know that 11 can't be the answer because m and n must be different numbers, right? So that's crossed out. Now, what else do we know? Well, we kind of have to try the other choices, right? Now, it's not really that bad because 31 times 13 we really have to try, and 21 times 12. Everyone sees that, and that's really going to give us what we want. Now, 31 times 13 is 403, and 21 times 12 is 252. Now, it can't be 31 or 13 because take a look at the product. It's 403. Does that look like NKN2? No, because the same number should be in the hundreds digit as the same number in the ones digit. And we have 4 here and 3 here, so clearly 31 and 13 are bad. Now, 21 times 12 is 252. And whoa, looks like we have a winner. Looks like we have a winner. So 21 times 12 is 252. Now you got to be very careful. It says that mn times nm is equal to 252, right? Now take a look. That means that n is 1. But it says the product will be nkn. So what happened here? Is n 1? No, n is 2. Whoa, we have a disrupt. So what can you do? Easy. Just commutator property. 21 times 12 is 12 times 21. And that's going to equal 252. Everyone sees that? You have to make sure that that's n because it's mn. So that's n, and therefore you're golden. Got it? You asked, what is the two-digit number mn? That's n. That's m. So it's going to be 12. Got it, guys? D. Think about it that way. Kind of interesting. All right, moving right along. Number 70. We did 70. 71, we did. 72, we did. 73. Okay, let's try to think. Now, the sum of p consecutive integers is 4. So now, in order to have, because 0 plus 1 plus 2 plus 3 does not equal to 4. 1 plus 2 plus 3 does not equal to 4. 1 plus 2 doesn't equal to 4. We know that there must be negative numbers. Got it, guys? Let's think. Let's think. So let me just erase. Do some erasing. Now let's think. Everyone sees 0 plus 1 plus 2 plus 3. Well, that creates what? 6, right? Well, I'm gonna try to equate that on this end. So negative 1 plus negative 2. Well, let me just try to write that. So negative 3 plus negative 2 plus negative 1 plus 0 plus 1 plus 2 plus 3. What am I at right now? I'm at 0. Everyone sees that? I am at exactly 0. Now, what can I do here? I want to sum of 4. Everyone sees that? Well, when I have that 4 here, because this plus this is equal to 0, because this plus this is going to cancel out, and then that plus 0 is going to be just 0. So 0 plus 4 is going to be 4. Everyone sees that? So how many consecutive integers do we have? 1, 2, 3, 4, 5, 6, 7. 7 consecutive integers. That's going to, what? 1, 2, 3, 4, 5, 6, 7, 8. I forgot to add that 4 in, so not 7, 8. 8. Can we go over 69 again? Yeah, sure we can. 69 is interesting. It's a really complicated problem. But the idea is that we know that mn times nm is equal to a 3-digit number nkn. So if we try the two possibilities, which is 31 times 13 that we're given and 21 times 12. 31 times 13 got it? And that means that mn cannot be 31, right? Because the first value is mn. Now, just changing mn to 13 is not going to work either, because 31 times 13 is equal to 13 times 31. So it cancels out a and c. Now we're between b and d. We canceled out e because we know that they're looking for values of mn, and there's no way that mn can be 11 because m must be different from n, and it says that over here. So we know that. Now we're left between 21 and 12. Well, 21 times 12 is 252, and we're golden because the same numbers in the hundreds place as the ones place. And that is exactly what we want. Right? That is exactly what we want. Now let's take a look. 21 times 12. Well, what's the problem? Do you see how that's supposed to be mn? And that's 1. So that means that n is 1. But is n 1? No, it's not. So you have to do the commutator property over here. And it's going to be 12 times 21, not 21 times 12, making mn 12. D. Okay, yeah. Got it, guys? All right, moving on. 74 is an interesting problem. We can't do this, Naeem. Your internet keeps zoning. I can't understand anything goes on and off. Well, I'm not entirely sure why it keeps zoning, but I'll tell you what, guys. There's nothing I can do today to fix it, but tomorrow, I guess we'll just start an hour earlier to try to compensate. Got it? So tomorrow, I guess we'll do 10 a.m. to 3 p.m. to try to compensate. I'm gonna try to fix my internet in the meantime. I guess that's the only way I can try to, get out of this jam. Right? I guess tomorrow we can do 10 a.m. to 3 p.m. Those of you who can make it at 10 a.m. can watch it on rewind. But if it keeps zoning off, I have to call my internet service provider and see what's happening, whether it's my microphone, whether it's the audio, whether it's my computer. I have to, isolate the variables. That's gonna take, an hour or two. Don't want to waste your time. So what I want you guys to do is continue to attempt the problems in the book, look at the explanations where you need help, and then unplugging and plugging my